Yeah, so hello everyone. This is the geometry class for STEMEY, and I just wanted to talk a little bit about STEMEY. So we are a high school organization, and we offer classes in STEM, and this one is for geometry. This is the trial run today. So we'll be going over all the subjects we're covering, and we'll be doing the first lesson. So let's just have all of the instructors introduce themselves. Hi, I'm Catherine. I'm a senior.
My name is Justin, and I'm also a senior at Lee High School.
I'm Tristy, I'm a freshman.
I'm Casey, and I'm a junior.
Hi, I'm Claire, and I'm a sophomore.
Okay, great. So now we've all introduced ourselves. Let's get started on the slideshow.
Let's first talk about all of the topics that we're going to be
Okay, yeah, I'll first talk about all the topics. So I'm just going to share my screen right now. This is a tentative schedule. So as you see, today's class will be on angles. Next class will be working on polygons, and then so on. And this will be up to the end of this year. So notice how we don't have a class on Thanksgiving weekend or the weekend after Christmas. Okay, so now we can get started on the actual angles, like we said.
Okay, so this week we are doing angles for the geometry class. So the first question we want to ask is, what is an angle? So I'm sure that you guys have some background knowledge in this, but an angle is essentially two lines or line segments or rays diverging from a vertex. They're just a degree to see how far apart the two lines, rays, or segments are. As you can see here on the leftmost picture, the angle is between the two rays, and you can see that the vertex is where they meet. Same with the middle picture in the triangle and the bisecting lines on the right picture.
So we'll go over the most basic types of angles. So we have, or the categories of angles, I should say. So we have an acute angle, which is a small angle that's less than 90 degrees. So it's between 0 and 9 degrees. As you see here, this is 30 degrees. Now a right angle is 90 degrees. So you've seen this before, like it's a corner of a square, like, or the side of the corner of a table. So like you see lots of right angles in real life as well. So straight line is a angle at 180 degrees. Obtuse angle is between 90 degrees and 180 degrees. As you see, this is 135 degrees, which is bigger than 90 and less than 180.
Okay, so remember last slide when we talked about straight angles, how a straight line is worth 180 degrees. So now when we have a line kind of in the middle of a straight line, as you can see here, the gray line is in the middle, X and Y on either side are going to add up to 180 degrees since they are both on the straight angle. And that is called supplementary angle. So X and Y are supplementary. Now, we know that since they're supplementary, X plus Y equals 180. So there's a lot of problems in math that you'll encounter where they'll give you one of the angles and then they'll ask you to find the other supplementary angle. And basically, if you look at the equations on the right, that's how you would do it. So if X plus Y equals 180 and X equals 40, as we can see here, then basically 40 plus something equals 180, and then you just solve from there.
So now we have a vertical angles. So these vertical angles are created when two lines are intersected. As you see here, look, you see y2 here and y1 here. You see x1 here and x2 here. And these will be considered vertical angles because they're opposite to each other. And then their angles actually have the same measure. So y2 and y1 have the same measure, x1, x2 have the same measure. You see here, if we actually give them, if we assign them numbers, then we see that the numbers are the same as well.
So the next term we should probably be familiar with is complementary angles. And this describes the concept when you have two angles that are making up 90 degrees. So in this picture here, you can see the purple angle or the purple lines forming the angle are 90 degrees. So if I were to say that Z was right there and X was right there, if you added those two together, you would get 90 degrees. So you can see here, if we're defining X as 60 degrees and we're solving for Z, you can say that Z is equal to 90 minus 60 and is therefore equal to 30 degrees.
So now let's cover parallel lines. So when there's a transversal, you see L3 that goes through both of these parallel lines. It cuts through two parallel lines, which is L1 and L2. So it creates identical angle measures near the intersection. So you see based off the vertical angles, you know that Y are the same. And then this is the it's coming in towards the same angle, so you know that these two Y's are the same as these two Y's. So it's really important to know this when you're solving problems, because if you, let's say you know that this Y right here is 30, they know that this Y right here is also 30.
Okay, the next is interior and exterior angles. So interior angles are angles that are inside a shape. So if you see X, Y, and Z, they are interior angles, while exterior angles are angles outside the shape. So X prime, Y prime, and Z prime. So for polygons that are not three-sided, the sum of interior angles are n minus 2 times 180. So n will be the number of sides. So if it was in like a polygon with 5 sides, then it'd be 5 minus 2 times 180. So the sum of interior angles in a triangle is 180. So x plus y plus z would equal 180 degrees. And the sum of exterior angles in a triangle is 360. So x prime plus y prime plus z prime is 360.
So before we go any farther, does anyone know what the sum of the interior angles for a polygon with 6 sides would be? You can either type in chat or just say it out loud. Yep, that's right, it's Avery. Anyone else have an answer? Okay, so for a polygon with 6 sides, some of the interior angles will be 720, like Avery said. So because this is because n, the amount of sides, is 6. 6 minus 2 equals 4 times 180, that's 720. So now let's have a little review before we'll stop sharing my screen. So does everyone know what a complementary angle is? Okay, you want to say it, Ishan?
So a complementary angle is an angle that, so when you add the two angles up, they're equal to 90 degrees.
Yeah, nice, good job. Okay, now see, does anyone know what a vertical angle is? So vertical angle is share my screen. When you see two lines like this, a vertical angle. Let's say if this is 30 degrees, then we know that this right here use different color. This right here is also 30 degrees. That's what vertical angle means. Okay, another term. Let's see. Can someone define a supplementary angle? Yep, that's right. Good job, Celine and Avery. They're up to 180 degrees. So let's have another problem. Let's see. Can someone tell me what's the red line called?
A transversal?
Yeah, good job, Yushan. So if we have a transversal, we know that this angle right here, this angle, and this angle are all equal. It's very important for solving problems with angles. So now so you guys don't have access to the problem. So okay, so I'll be splitting you guys into all into breakout rooms. Wait, first I have a question for all of you guys. How does the content feel? Like, is it too easy, too hard? Feel free to say it. Just the right level. You can private message me if you want. Okay, it's good level. That's good. So now obvious structures you guys should get on the angle problems. So you can go over the problems with everyone in the breakout room. So I'll be splitting us into 2 breakout rooms. So I've opened the rooms now.
Justin, do you want to share screen? And then
Yeah,
we
I'll
can...
share my screen and bring up the problems. So let's start with problem 1. So let's see, we have a 92-degree angle here. We have a 27-degree angle here. Can someone find the angle of x?
61?
Nice.
Yeah, and do you want to explain why that is for the other people? Ishan?
Okay, so the angles of a triangle add up to 180 degrees. So you add up the ones that you already know. 92 plus 27 is 119. And then 180 minus 119 is 61.
Nice, that was fast.
Yeah. Good explanation.
Okay, now keep in mind this is a 9-degree angle for number 2. Okay, yeah, good job. You guys really got it.
Yeah, same thing. There's 180 degrees in a triangle. That looks like a right angle, and then you could just go from there.
Mm-hmm. Okay, now number 3. Nice. Yeah, I think we might have to do whiteboard problems now.
Yeah, you guys are ripping through these really
You're
fast.
doing really well. Okay. So what is the sum of the angles marked? Okay, nice. Okay, name this angle. Number 5. Oh, sorry. I was the one I was looking for is just as ABC because yeah, but then you're right that it
Acute-
is an acute angle. Now for number 6, can someone solve for x? Nice. And each one, would you like to explain to everyone?
So we just set up an equation: x plus 3x plus 10 is equal to 90. So then we get 4x plus 10 is equal to 90. Then 4x is equal to 80. X is equal to 20.
Nice, good explanation. Okay, for number 7, solve for x. Nice.
Yeah, there's 2 ways to do this one. Either you can do like there's 180 degrees in a straight line or 360 degrees in a circle, whichever one you prefer.
Okay, and do you guys mind if I ask you what grade you guys are in so I can better plan like future classes to be more of your level? Nice. Okay. Okay. Okay, yeah, so I can, in the future, I'll definitely make the classes harder. Yeah, that's good. It's always good to challenge yourself. Okay, so this number 8 should be really easy for you guys. Okay, good. So I'll pull up whiteboard problems. Give me 1 second. Can you guys solve for x here? Hopefully this is a little more challenging than the previous problems. See if anyone else has an answer. Okay, good. Okay, nice. See, Hmm. Okay, yeah. You guys solve this?
Wait, is that 15 or is that 150?
Where? Which one?
The one to the right of
It's
the
15.
Okay.
Or X? I just made this problem off my head, so I should probably actually work on it now. Oh, sorry. I probably should have told you that this is a parallelogram.
Yeah, but
Yeah, I hope you guys figured it out. This is a 180-degree angle. This would be 5 plus.
115.
Yeah, this would be 115.
Mm-hmm.
Total, that would be this would be 130.
So
So
isn't
then
the other side also
this would
It would be
this would be 130 as
15.
well.
and then X is 15?
Yep.
Wait, for which one?
Yeah, X would be 15.
Mm-hmm. Nice. Let's see. I'll look up actually AMC problems for you guys
Yeah,
to do.
I found a good problem. Do you want me to share my screen?
Yeah.
Okay, so just solve for I and N and tell us if you need any help or let us know when you're done. You know, I should probably do this as well. So
What do you solve for?
I and N.
Yeah.
Using vertical angles would be very helpful in this situation, and knowing that triangles are 180 and quadrilaterals are 360.
Yeah, also supplementary angles are also important. Yeah, I'll just solve N first, but yeah. Okay, I got that for N. Okay, nice. Do you guys want to try it out as well, or you guys just want to move on? Okay, you guys good. Okay.
Wait, what? Should I stop sharing?
Yeah, I'll look up AMC problems for them to do. See, yes, AMC 10 problems then.
Hey, Sean, are you planning on taking the AMC 8?
Yeah.
Yeah.
What's your high
Good.
score?
My high score, I took it like 2 years ago in 5th grade, and I got like 20. But
Oh wow.
Damn. Sorry, but wow.
Yeah, I'd say I remember middle school, like my 6th grade record was like around 20, and then afterwards I stopped doing competition not to focus more on school. Let's see. Share my screen.
Memories. Wow.
Okay, sounds good, Shristi. Can guess. I thought I'd actually do this as well. Half guess, okay. This is great now. Yep, it's D. If you guys want to read into a solution, I'll leave it up for like a minute. Yep. DBA, yeah. explanation. Let's see. Let's see if it says it's right angle. B is parallel to DC. Parallel to D. We know that. I don't think we can assume. We know that AB and ED are parallel, but we don't know if AE is perpendicular to either. It'll be too easy if you can assume, because this is 40, this is 50, and then yeah. I think 130. Okay. We'll give Ishan the chance to answer. Okay. Yeah. Okay, nice. So here's the solution. Celine, do you want to explain why you think how you got 130? Oh wait. Oh, this is diameter, yeah, so this is 180. And it is 9-degree angle for EAB.
I just did 180 minus 50.
Okay. Look at this. Okay, let's see what the correctors say. You're not wrong. The other ones are. Let's see. Yeah. So it's B. I'll leave the solution up 4 bits so you guys can see. Does that make sense? Yeah, you almost got there. Yeah, we've done 1/2. Okay, this is too easy. I'll go about this one. Yeah, okay. Does anyone else agree with the answer that Isha has? Okay, so yeah, that this is a 75. This ratio adds up to 180. So here's a total of 6 parts of B. So that's 75, 75, 30, 75, and then isosceles triangle. So this would be 52.5, 52.5. Okay, now let's try this problem. Okay, it's okay. Was it like the interpretation of the problem or like more of like the solving part? Okay, yeah. Sometimes the problems are worded like weirdly. There isn't too much angle stuff, but still try this problem. Catherine's here. Okay, you can explain this problem now.
Wait, I have not looked at this problem.
My sister's here and she's better at math than me, so yeah.
Wait, hold on, what am I reading? Okay. Center. I should probably draw this out.
We should draw.
Yeah, maybe we should all get some paper. That might be helpful.
Yeah, you definitely need paper to help you visualize this.
Okay. BD over BO. Okay. 60 degrees. Okay. So that's a 90-degree angle. That's 60. So that's 30. Okay, so then that's x over 2. 2. So also just I think we should turn on annotations.
How do you do that?
Diameter.
Half a thing. Be honest here. that's fair. We're doing on paper now. Okay, that's good.
Good.
We're using variables for that one. Just think of it as like a unit circle, maybe.
I don't think you need that. You just need x, right?
Yeah, you can use X, or like if you don't want variables, you think of it as a
How
unit
long have you
circle.
guys been working on this problem?
Let's see.
Should we go over it soon, or is it more time?
Let's go over it in a minute.
Okay. Okay, so does someone want to explain how they got it, or should I kind of do it with you guys? Okay, I'm gonna share a whiteboard.
Okay, I'll stop sharing.
Okay. So we have circle, and then we have like kind of like this thing, right? Like that. This is A, B, C. This is O. This is O, and then was this D? I don't remember. Was this D, Justin?
Yeah, I'm on the problem.
Okay, so
Yeah, it's the intersection of
let's just connect this to this, right? Because this is a tangent. So what do we know about this angle?
90?
Yeah, 90. So this is 90. And what's this angle? Just this side. This side.
30?
Yeah, 30. So this is a 30, 60, 90 triangle. Okay, so let's just call this entire length, this BO, let's call that X. Then what do we know about this side?
X over 2?
X over 2. Yeah. Okay, so well, I think now we can find our answer, right? So what's DO then?
X over 2.
Yeah, X over 2, because they're both the radius. So is it BD over BO? Is that the question?
BD over BO,
Yeah,
yeah.
so we know DO is X over 2, so then BD plus DO was X. So we know that this side is also X over 2. Divided by BO, that's X. Yay, 1 over 2. We did it, guys. Okay.
Okay, should we end this class to go to prepare for algebra?
Yeah, okay, so next time we'll come up with harder questions so that y'all aren't like bored or
I
something.
think we can really skip the polygon unit.
No, we are not skipping the polygon unit. We are coming up with competition math problems for it. I don't have a competition math class this time, and like I teach competition math, so yeah, I'll come up with questions
Okay,
or
good.
assign questions. Yeah.
Catherine, yeah, you guys, you can just be assigned with these 3 next time.
Yeah. Okay, and also next time in the breakout room, we don't need to record. Right.
Oh, okay, yeah, that's right.
Yeah.
I
We'll
forgot I
cut
was
the
recording.
recording. Okay, yeah.